Hi everyone, welcome. Today we're going to be doing Leetcode problem number 226, Invert Binary Tree. So the problem is stating, given the root of a binary tree, invert the tree and return its root. So an inverted tree is basically when you are switching the children of a node. So if you just had a tree that consisted of one root with two children, then it would just be that same root, but with the children flipped. But we have to do it for the entire tree, so within each subtree, we're flipping every pair of children, right and left. So this could be done with depth first search, with like a recursive methodology, or it could be done with a breadth first search where we use a queue and we are doing it iteratively. So I'm going to go ahead and try to do both of those for you just so you can see the difference. So let's start out with the breadth first search approach. So I'm going to import collections so that we can use a queue. So, a deck, which is serving as our queue, and then I'm going to append the root to that queue, and then I'm going to say while the length of queue is greater than 0, we can pop the root. So we'll say queue.pop left. And then that is now our node, and now we want to say if the node exists, we want to do certain things. So we want to do the actual switch, which will be us creating a temporary variable and storing the left there, and then setting the right to the left, and then setting the left equal to the right, and then setting the right equal to the temporary variable. And then we also want to call this, we're not doing recursively yet. We want to add the right and left child to the queue. So we're going to say queue.append node.left and queue.append node.right. And this should take care of it. At the end, all we need to do is return root because we're doing this in place. We're not like creating a new tree somewhere. So let's go ahead and run this and see if it works. And it does. Let's just see if it works for all submission or all test cases, and it does. So that is our breadth first search approach. Let's try this with a depth first search approach, which would be a recursive approach. So let's say that our first, our base case will be if root not root, right? So we're checking to see if the root is null or if it does not exist. So if it does not exist, we're going to return none. Okay? If it does exist, then we want to do the flip, right? So we are going to call this recursively on the left and the right subtrees. So let's do that first. So left equals, we're going to store it in a variable called left. Okay, so left equals self.invert tree root.left, and then right equals self.invert tree root.right. Okay, and now we are going to do the flip. So we're going to say root.right equals left, and then root.left equals right. That's the flip, and then we're going to return root. That works. And that works for that first test case, and it also is accepted for all test cases. So there you go. That is how you solve Leetcode problem number 226, invert binary tree, with both a recursive depth first search approach as well as a iterative breadth first search approach. And they both have a runtime of O of n, because n being the number of nodes, because in the queue situation, we are going to have to iterate through every node, as well as the recursive situation, we are going to have to iterate through every node so that we can do the inversion. So hope that helps, and thanks for watching.